So question 10 says, calculate the centripetal force on the Earth as it rotates around the sun. The mass of the Earth is 6 times 10 to the 24th kilograms, and the Earth orbits the sun in a circular orbit of 1.5 times 10 to 11 meters in 1 year. So what we're going to have to do is we're going to have to get some of our values into SI units. So 6.0 times 10 to the 24 kilograms. And then our radius is 1.5 times 10 to the 11 meters. So defined centripetal force, that is simply mass times centripetal acceleration, which that is going to be v squared, which is going to be mass times velocity squared over r. So the first thing we need to do really is just find velocity, and then we can plug that in and we know everything else, so we can find our centripetal force. So velocity is going to be a distance divided by time, and that's tangential velocity. So if we are talking about, here's our sun, and then the Earth out here, and it orbits around that in a year, right? So the distance is that circumference. So that's 2 pi r, there's r right there, divided by our time. And so 1 year, so our time is going to be 1 year, which is equal to 365 days. And we're going to convert that into seconds, which when I get that to seconds, that's going to be 3.1536, whoopsie, times 10, 1, 2, 3, 4, 5, 6, 7 seconds. All right, and we need to do that because we can't get something in newtons for forces unless our velocity is in meters per second. So that's the reason why we need to do that. So what's my velocity? So that's 2, so we have 2 times pi times my radius, 1.5 times 10 to the 11, divided by 3.1536 times 10 to the 7. And that's going to give me a velocity of 2.99 times 10 to the 4th meters per second. So that's how fast we're going. And then we can simply just plug that value in here for my velocity. We already know my mass, and we know my distance as well. So if we were to do that, our centripetal force is going to equal our mass, which is 6 times 10 to the 24, times our velocity, which is 2.99 times 10 to the 4th, that value squared, divided by my radius, which is 1.5 times 10 to the 11th. And that's going to give me a value of 3.6 times 10 to the 22 newtons. So a large force that's acting on the Earth due to the sun, and we can simply find that value by simply knowing the mass of the sun, or excuse me, the mass of the Earth, how far we are from the sun, and then obviously our time as it goes around.